All right, and we are live. So, hello everyone, and welcome again to the Kubernetes Security and Observability Summit. I am your host for this panel, the live panel we have today on cybersecurity and the cybersecurity threats that exist in the cloud. And today I have an amazing panel with me. I have Ofer Moore, Shabo Long, and Alex Schulman, and I'm going to turn it over to the panelists to introduce themselves before we get into the questions. Let's start with you, Alex.
Thank you. Alex Schulman, leading the cloud security practice of EY in the Americas. Overall, I'm in cloud security for more than 12 years, developed products, developed security features for clouds. In my last role, I was lucky to work with Shabo at Citibank, where I established and led CISO Cloud Security Program and Cloud Native Security Engineering. Excited to be with all of you today.
Great to have you here, Alex. Ofer?
Hi, thank you. So my name is Ofer Moore. I'm the CTO and co-founder of Mitiga, a company focused on cloud incident response, helping those who unfortunately already got breached in the cloud. We see quite an uprising of attacks in the clouds, as probably you're all aware. So this is becoming a very interesting space. I've been doing cybersecurity for 25 years, founded multiple companies in this space, did a lot of work around Devops and CI/CD and application security, and now in cloud security.
Great, nice to have you, Ofer. Shabo?
Hi everyone, my name is Shabo. I'm a senior VP in Citibank. I manage a group of cloud security engineers. So my team delivers critical security solutions to secure cities' cloud environment. So to enable city business to leverage cloud while staying secure and offline. I worked with Alex before, and it was really great experience. So before I joined InCity, I worked for Goldman Sachs for 6 years after my PhD. So today I'm very happy to be here to share with you all about my view of cybersecurity in Kubernetes, what problems are we trying to solve, what best practice we have been using, as well as what lessons we learned during our cloud journey.
Great. Thanks for the introduction as well, Shabo. Great. I'm really excited to have the panel here. One of the things that, as you think about Kubernetes, what happens is, especially when it comes to cybersecurity, and as we look at all the reports today that come out, you see that cybersecurity is a big challenge, especially in a post-pandemic environment where more people are working from home. There are remote connections. There are, with 5G, there are more network devices or IoT devices that are getting added to the network. And so, cybersecurity ends up being one of the biggest concerns on the top of minds of CISOs, on top of minds of everybody who is in charge of security. And as you saw in the keynote address by Ratan this morning, that containers are taking off, and Kubernetes is becoming the default orchestration standard for containers, which means that all these cybersecurity threats that we're talking about are very applicable in the Kubernetes environment. So before we just get started and talk about cyber threats and modeling, I think it'd be great to understand what is so peculiar about Kubernetes that makes it especially vulnerable to cyber attacks. So maybe we'll start with you, Ofer.
Thank you, Bill. So I think we need to be careful in blaming the architecture as much as discussing the differences. And so I think one of the biggest challenges is Kubernetes is different, right? It's different in the sense that it's not the traditional hosts that we see even in some of the cloud infrastructures where there's a clear security policy and patch management, but rather a lot of smaller containers that are created instantly and ad hoc. And it's just a different culture. And what we see is that this culture is driven by developers, by DevOps, and the traditional security controls and approaches simply don't apply there. We just saw with one of our customers we simulated an attack, and we saw that the way they were building their privileges for Docker containers between different customers had the wrong set of privileges and could allow any customer to potentially take over all the instances of containers of all the rest of the customers. And the reason for this is that it requires different sets of security controls. It requires different sets of skills that the traditional security team don't usually have, and the developers and DevOps don't always have the awareness. And so it's a lot about configuration. It's a lot about lack of tools. And this creates an amazing attack surface that attackers are taking advantage of.
And if I may, can I also add
sure.
maybe to the topic, and I'm sure all of us can add more and more attack scenarios. But there is one fundamental difference that makes container platforms different from all the rest. And it is the fact that containers running on the same host share the same Linux kernel. This is just the fundamental things of containers. But because of this, it is much easier to exploit a vulnerability, for example, of one application to take down the entire cluster because of the shared kernel. Because any kernel exploit can be used to break all the containers running on the same host and then to propagate and take the entire platform down. And we do not have the same risk in traditional environments where we have different virtual machines and each machine has a separate kernel. So I think this architectural difference is very critical to understand the threat landscape, because there are multiple attacks that are much easier to execute in container environments, and the blast radius is much bigger. So this is one of the reasons. But in addition, as Ofer mentioned, right, configuration is much more difficult. This shift left requires a lot of investment from the developers, and they need to understand all of these risks and threats. And today, they're not doing this in the traditional environments.
Got it. No, that's really helpful. So maybe I think just to help our attendees kind of anchor this using some examples. And Shavo, you've been in the space for a long time as a practitioner. So as a practitioner, give us an example of all the things that Alex mentioned and Ofer mentioned as vulnerabilities and as the attack surface with the sharing of the Linux kernel. What are some examples of attacks and how would these be exploited in order to gain control of your environment?
Sure. So I work for financial companies. So firstly, the cyber criminals target everyone, not just financial institutes. But since I have been in this field, I see some critical applications or platforms that almost all the banks are using. And those are extremely attractive for the cyber criminals to target with. So one example is SWIFT. So if you look at the wiki, SWIFT is called Society of Worldwide Interbank Financial Telecommunications. You will see that as of 2015, SWIFT linked more than 11,000 financial institutes in more than 200 countries, carrying an average of 32 million financial messages per day. Therefore, in 2015 and 2016, a series of cyber attacks using SWIFT backing network were reported, and millions of dollars were stolen. One of the tactics that cyber criminals use to steal money from SWIFT was lateral movement. So that means if the cyber criminal compromises one vulnerable system, can be a web server, he or she can leverage the flat network to harvest the data. So after a few major breaches, all the financial institutes go together and they build this customer security program, which requires all the banks to have their payment system ring-fenced in a dedicated secure zone and protected by firewalls. And if one bank doesn't do it, the other banks can decide not to do business with you anymore because you are not secured. So in the past 5 years, you can see many financial institutes have already developed network segmentation solutions for SWIFT for those applications running on the physical servers or virtual machines. And now our business start to migrate those SWIFT applications from physical server and virtual machines to containers, and even to public cloud, Google. So how do we do network segmentation in a Kubernetes environment brings new challenges for us. Yeah, so that's what I saw.
As I was navigating the various controls, we have almost like a cockpit, like a set of controls here. But no, that's a great example. Thanks, and I think it's very fascinating. I mean, I didn't realize that the scale of communication that happens on Swift, and of course how it needs to be secure in a Kubernetes environment. So I think one of the features we have on this platform is a poll, and I'm going to open up a poll for the audience here to see if what the audience thinks. And while the poll is getting answered, we can move on to the next segment of this panel. So now that we understand that Kubernetes is different, attack surface is different, and some of the traditional ways of securing your environments may have to be you may have to rethink some of those ways. So let's just start right at that point, right? So now if somebody is considering moving over to containers to Kubernetes, what are the cyber both threat modeling and threat hunting strategies and approaches that an organization should consider? So once again, let's we can go back to I don't know, Ofer, why don't you start, and then we can go to the panel.
So when we're talking about threat hunting, I'll present the incident response perspective, and I let Alex talk more about the earlier stages. I think when we look at incident response in Kubernetes, one of the biggest challenges is the fact that it's very ad hoc. A lot of the architectures we see are all about creating containers, using them for a while, and then dropping them. And so a lot of the evidence that is created during potential breaches disappears. And this is a huge challenge, and there are ways to overcome that, but most of the customers we see don't do that sufficiently. And so it becomes very difficult. Add to that, and that relates to what Alex said before, that in most Kubernetes deployment, there are insufficient controls, and lateral movement becomes very easy across the different environments, different containers and network segmentations. It means that hunting there is extremely difficult, and incident response is extremely difficult. And the approach that needs to be taken is in the readiness area. It's how do I prepare my Kubernetes environment, not just to be more secure, which is of course important, but also to be better ready for potential breaches. How do I get logging out of the pods and into a persistent repository? How do I get things alerted and monitored in real time, so I don't lose the important forensics data and evidence data that allows me to hunt and investigate once the container is gone.
Got it. So anything that you would like to add to that, Alex, in terms of a little bit early stage in terms of just the modeling step itself?
Yes, definitely. And first of all, let me also add the incident response, because what Ofer has mentioned, this is very critical. Like the same tools that are being used on-prem will not work for incident response and investigation in container environments. So for this, organizations need to prepare. They need, in many cases, for example, organizations are collecting logs from their cloud environment, but they're not paying attention that actually they need to collect separate logs from the container platform, from all the pods, as Ofer mentioned. So it's about logging and monitoring. It is a
It looks like we're having some audio challenges with Alex. I don't know if you wanted to continue the track that she was on.
Yeah. So, you're back.
Yes. So let me just finish that. It is about logging, monitoring, and ability to quickly react, first of all, snapshotting the instances and getting the data that is needed for the investigation, and sometimes using additional security products or tools like agents running on the hosts that can help with this. But Arthur, you want to add something as well?
Yeah, I think one of the challenges, and I see that when I talk to some people, they're talking about, sure, I keep the Kubernetes logs, right? So we need to just make sure we understand the difference between the logs of the Kubernetes infrastructure, the Docker infrastructure that's inside the Kubernetes, and the logs of the specific operating system or the chunk of the operating system that's running inside the pod, that's doing the work, because that's the one that is probably going to hold a lot of the important data, of course, application log, but also the infrastructure of that environment. And that is often omitted.
Got it. Got it. So yeah, that actually makes it quite challenging, because you have to stitch together all these logs. You have the logs of the infrastructure that are talking about your resources of the infrastructure. Then you have Kubernetes logs with pods and namespaces, and of course then the applications. And in order to construct them, you have to stitch it all together. Wow, that is indeed a complex problem. Yeah.
And I could add another challenge, and I think some of these challenges are not yet entirely solved in the industry. This generates a lot of data, a lot of logs. So if you're just going to say, oh, I'm just going to stream all this to my SIM product, you're going to discover that the cost is getting unreasonable, because there's so many tiny pieces of infrastructure all generating tons of logs. And so it's massive amounts of data from one hand, but you can't just let it go from the other hand. And so there are a lot of challenges about how do you manage the data, which parts of it do you keep, how do you keep it, and where, that will make you better for incident response and hunting without the cost being unmanageable.
Got it. And I imagine that for incident response and hunting, it's probably a very small subset of data that you're looking for. It's almost like you're looking for a needle in a haystack as you're collecting so much data, but the actual discovery of that problem area is equally troublesome, I imagine.
Yeah, it's a needle that you look for, but it's the haystack that you need to collect. And so these are part of the challenges that we deal with continuously. The cloud just introduces, the cloud general, Kubernetes specifically, introduces completely new challenges in this incident response space. Enormous amounts of data that are just hard to process and find stuff in. I maybe want to add one more thing. When we talk about threat modeling and vulnerability testing in Kubernetes, again, because of the things that Alex mentioned, because of the things that we talked about now, a lot of the assessments, pen testing, audits that we're used to do don't apply perfectly to Kubernetes environment. You can transform to them, of course, but you need the right people. And if you bring your usual security architect or usual pen tester to look at a Kubernetes environment, if they don't know Kubernetes, if they don't understand the differences and what the containerization means, they're going to miss a lot of things. And that's another threat.
Got it.
Let me add to this. Actually, this requires transformation of all of the pieces of the organization and all the processes. As you mentioned, even pen testing processes are different. And you mentioned audit. As an audit firm, as EY, we're doing multiple assurance projects or audits, and this is what we're looking for. So we're indeed investing in looking deep at the Kubernetes level because of this understanding of exactly what Arthur mentioned, that all of the pillars need to adjust and to look at these specific threats and risks. And to assess the controls at the high level are the same, but the way we're assessing them in the context of the Kubernetes environment is slightly different.
Got it. That's excellent. That's a great framing, and it's almost you can think about in terms of frameworks and people and processes and tools, and they all kind of play very important role in both the modeling and the hunting part of it. So maybe, Shavo, tell us, from your perspective, your view on how these frameworks and processes and people challenges or need to be thought through as you are applying these techniques to a Kubernetes environment.
Yeah, sure. I think Alex and Oliver got some very important points. That is, the traditional way to do risk assessment or threat modeling will not work for this cloud, because traditionally the vulnerability assessment team will do a pen testing, and they will generate a 20 pages long PDF file for the application owner to read, to say, hey, you have this and this problem you have to fix in 1 week. And those are low risk issues you can fix after three months, something like that. They will not tell you how to fix the problem. So the way we are pushing forward is to do threat modeling as part of the engineering process by this whole shift left. For example, security team can provide the vulnerability scanning services in a pipeline before the images are deployed. And even better, we can give application owner some early feedback in their IDE tools when they are still writing the code, to provide some spelling check button in the editor. The tool would tell you which line of your code needs to be fixed to pass our security posture checking. So that is a technology we are looking for to implement these thoughts.
Yes. Okay, and let me strengthen this because this is a very critical point. Shifting this left to the developers, because security teams will never scale. So Shavo, fully agree with you that the more we can give this to the developers, so that they will have visibility on understanding of what is needed and visibility on the current situation, and that's the only way to move.
I wanna add on this. I think we're all shifting left. I spent most of my career in software security and in shifting left, and it sounds great, but I think most people don't really understand what it takes. And so it's not just about giving developers control or more encouragement to be part of the process, because unfortunately, and we see this, we've been doing shift left for 15 years in various names, they will never fully own it. I see that everywhere I go, even with my own development team, right? We're a security company. They're very security aware, but they're still not security people. So they do their best, but that's not always enough. So shifting left means not just having the developers more security aware, but having the security team be more of developers. Having people on the security team that can be part of the development team, that can work with them, that can interact with them and talk their language. And I think that's one of the biggest challenges in this space. It's how do I bring security developers to the security team to work with the developers on the shift left process. And getting this right is a big win.
So I would suggest we should put the engineering or application developer and the security experts in the same room to do threat modeling, because threat modeling is all about to understand what are we building and what can go wrong. So the output of threat modeling should be like Jira tickets assigned to both application team, engineering team, and the security team. The engineering owner will take the Jira and go back to their architecture to reduce the risk. And the security team will need to develop additional preventive control or detective control, either in the pipeline or in the runtime, and then feed the actionable alerts to our security operations center and incident response, and connect all the forensic them for them to capture the bad guy or girl, right? So only the control is within SOC and IR, the secure operations center. We can say that the control is implemented end to end, but this whole streamline of process needs to be in place.
Exactly, and let me add also that maybe we should be viewing all of the security issues in the same way as we're viewing code stability or safety issues. So they should be part of the same process, part of the same product management process from the software standpoint, so that these are the same JIRA tickets and the release is not released until critical issues are not resolved. And right now, unfortunately, in many cases, we're treating all the security issues separately. And this is why it is so difficult, because the more we can align this with the software product development, the easier it is for everyone.
Got it. That's super profound. I think this the fact that, offers explanation on what shift left means and how you're actually applying it at City, and Alex, you're applying it in your world. So as we look at processes, and of course we discussed, processes have to change, frameworks have to change. We have to have the roles, how people interact have to change. What about tools and technologies? Does Kubernetes require very specific tools and technologies, or can you rely on what's already available?
So I'll start. I think the answer is twofold. I think there is needs for capabilities, for new capabilities around Kubernetes, so that come in new tools, or that can come through the adaptation of existing tools to Kubernetes, right? Because it won't just work out of the box the same, because if it's a tool that needs an agent to collect data and that's not part of the pod, you're not there. And of course, you can try and force it to install that on every pod, but that's just not using this platform correctly, right? So you need tools that know how to run inside a Kubernetes environment and interact with the different containers and collect the data or monitor the data. And I think we see some vendors going in this space in adding capabilities to existing technologies to better support Kubernetes. I'm sure there are going to be a lot of areas where new tools that are Kubernetes native will do much better.
Got it. Excellent. So we have, before we move on to our the next segment, and we have some questions from the audience, and I would like to pose them to the panel here. So the first question is, what is the first cybersecurity challenge that I'm most likely to face if I'm a new Kubernetes user? Does anybody want to take that one?
Go ahead, Alex.
I would start with the basic hygiene of what goes into the platform, right? Ensuring that you're not bringing vulnerable containers into your platform. I would say that this is the first step. Just ensure the hygiene of the platform, and the cleaner it is, the more secure it is.
Yeah, I think it's a great answer. Add to that, and again, that depends on your architecture, but probably the separation of the different containers, and depending on your needs. But that's where we see a lot of people come short, between containers and the host, between containers and between each of the containers, because you create a microservices distributed architecture that is supposed to have a front end and a back end and secure areas, and then everything is on a flat network and can easily get compromised.
Yes, wear a mask to isolate between containers. We don't want to mix potentially vulnerable, poorly written containers open to the internet with Swift or other most critical applications, because that's this will put everything at risk. So great point of view.
Got it. And Shah, what would be your top number one if you wanted to add to this?
Yeah, so I think depends on which applications. If at OApps top 10, like cross-site scripting, those things applies no matter if you are running application in container or not. So think about application security, think about the platform security, as Offer and Alex mentioned. So that's That is how would I tackle this problem.
Right. There are a couple of questions. I think one question was really about, I think, talking about lateral movement, and a question about, has anybody on the panel had experience dealing with a specific lateral movement attack, like the man in the middle attack, and how would you go about securing an environment in that situation?
So if you go to the MITRE framework site, there is a tactic called lateral movement. It will give you the TTP, what techniques the hackers can do to make a lateral movement. So usually they use some management ports. They use SMB, SSH, or RDP to move around. And there are also like a pass the hash attack. So I think the MITRE framework gives a very detailed description of the techniques the hackers can use.
Got it. All right, so let's switch gears and actually help the audience with implementation. And I think, Shabo, we lost your video, so I'm not sure if it was intentional, but would love to have you back.
I still see her video.
Oh, you still see her video? Okay.
Camera.
But it's just, again, the quirkiness of the platform. But hey, that's the fun part of virtual platforms. So I just wanted to switch gears and talk a little bit about how would it work in the real world, right? Because one of the things that you see is organizations will have a mix of applications. Not every application will be containerized. Not every application will be based on Kubernetes. And you have existing processes, you have team organizations, you have tools. So help us understand from a CISO's perspective or from a platform owner's perspective, if they are going big time into Kubernetes, what are some of the existing challenges? What are the challenges that they're most likely to face when it comes to people, when it comes to organizational challenges, people challenges, technology challenges?
So I think, I'll repeat myself a little bit, but I think the biggest challenge is...
Maybe I can take this one. My recommendation is actually to build these integrative teams, because Kubernetes platform is any cloud platform. It combines so many things. It combines network management with identity and access management, and covers all of the traditional security domains. So I would recommend looking at this in a holistic way, bringing cross-functional teams, first in the security of the platform, and then in the secure management of applications above it. And there are multiple processes that should be established for the platform management and then also for application management. As Ofer mentioned, right, we need to have rules not to put applications that cannot be placed on the same platform together, because one application may be putting another application at risk. Right now, most of the enterprise risk management systems, they're looking at each application separately. So we have data classification, we have various attributes for each application, and it is assessed just in itself, right? Can this application be deployed over Kubernetes, for example? We don't have typically these enterprise systems mapping these cross dependencies, saying that if you are deploying this application over Kubernetes, you need to have a dedicated cluster because of the sensitivity of this application. So in many organizations, we don't have this as part of risk management processes. And so this is why we need to build this holistic view for Kubernetes platform, including risk management, including these container-specific risks, should be part of the decision-making processes. So we can view this as part of the path to production. Before each application is allowed to go into container environments, there are certain rules that should apply to this application based on its data classification, for example.
Yes,
so it's about enterprise management processes and path to production, integrating all the new risks.
Yeah, I think those are really great points, Alex. I wanna add something on maybe a slightly different perspective. I think, and I keep going back to that. I think one of the biggest challenges, and we see that, and especially in organizations that are a little less developed than the big financials and so on, is getting the right people in place and not compromising there. Because what we see is, a lot of these organizations have a lot of security people. Oh, we lost Alex. Have a lot of security people that are very traditional. They've been doing this for a decade. They know security really well, but they just don't understand the nuances that a Docker Kubernetes environment creates. And there are two ways to tackle it, right? Either you bring somebody, which is very hard because we have a terrible shortage of talent, or you identify the people in your team that get excited about it, that find this cool, and you invest in them. And there's a risk, right? Because once they know Kubernetes security, they become much more lucrative, and somebody will try to steal them off. But still, you've got to find the people that are really into this and want to get it. Because if they don't get it, it will be very hard. I think one of the biggest shifts we've seen, I started in security 25 years ago. Most security people were IT people that got fed of being IT people and moved to security. And they had really strong IT background. We want to see the same people in cloud security, but we don't, because cloud IT people don't move. It's just beginning. It's a cool area. Why would they move to a new career? And so we need to find a way to find those people that get excited and train them and bring this knowledge into the security team. Otherwise, you put them in a room with the DevOps guys, and it's just a clash. It's a clash of, legacy security approach with cool DevOps guys that want to do fun stuff and CI/CD and Kubernetes.
That's very fascinating, this clash. So Alex, maybe from how are you folks organized? What is how do you get the security and the DevOps team to work together, and how have you tried to solve this problem? Chavo?
So firstly, we have a cloud security engineering team who understand cloud and cybersecurity. And we start from the not the business application owner. We started with the platform owner, like the guys who is doing DNS. Those are critical services. The guys who are doing the shared services that can be used by multiple applications. Then we do threat modeling together. So it is all about to ask the right questions, and the application owner or platform engineering owner, they know in and out for the application they own. They can help us to understand the data flow, and that is a very input to the threat modeling. And then we can ask them questions: what happens if? Can you think about this scenario? What can go wrong? So as long as we brainstorm together, I don't really think there is a big gap that we don't speak the same language.
Right. So that's pretty from a people perspective, and I think I just want to make sure I actually just announce quickly for the attendees. Alex is having some technical difficulty. She was logged in from her cell phone, but unfortunately she's not able to connect. So we're trying to solve that and have her back on. But in the meantime, let's just continue with our conversation here with Ofer and Chavo. So with regard to people and to getting them to work together, what is the role of processes? And are there, when it comes to the CI/CD process, the whole application deployment process, what are some of the process elements that can be put in place to make sure that applications are secure, that you are putting in the right practices with Kubernetes?
Yeah, the first thing we can do is, for example, for a particular cloud environment, and say everything needs to be deployed through the pipeline. So no one will have any manual touch point. So if we do the pipeline, we can put policy as code. There are tools to check the code, scan static coding, and find out, hey, your code cannot be passed because of this and that security issues. So this is the first thing we can do. And then for any new applications going to cloud, we can have a review process, start from threat modeling and architecture review, and only it gets passed by the committee to say, hey, your architecture is good with all these controls in Jira, then we open the door. So there are something we can do at the organization level to enforce this process.
I think one of the challenges in this space is finding the right balance between the controls that could potentially slow down the DevOps process, right? The CI/CD process, and the need to keep security. And so what we've been trying to implement in my last place is what we call the trains model, right? When you have Rails, you have slow-moving trains and fast-moving trains, and they work in parallel. And you want to implement the same thing for CI/CD and DevOps approaches. So we can keep the CI/CD moving, right? CI/CD could be 2-week sprints, could be having a feature out every hour. And if we stop everything and move everything to an audit and review, we can become the bottleneck that slows down CI/CD and introduces, other risks that are not security. And so the idea is to build a mechanism that allows where automation works and works well, right? If it's static analysis, if it's scanning, anything that's automated and can happen in real time can work as part of the fast track. And it only blocks if it's really critical or severe. Otherwise, it just warns or sets a process in place for mitigation. And everything else that's not as fast or critical goes to the slow track and then works in parallel. And this process creates tickets, creates things that needs to be fixed, but doesn't block the process. And by creating this of fast and slow processes, you can still keep good security while not engaging, while not annoying the DevOps team. Because if you start blocking every build, you'll be thrown out of the discussion.
Yeah, absolutely. So our goal is to enable the business. We don't want to be the blockers. So again, this goes back to security as a service. What exactly can we do? So for example, we encourage people to use Terraform. Then we provide the Terraform modules for them to leverage. In the Terraform module, we already have hardened a lot of security things, like all the operating system images already secured, hardened. And if they want to use AWS, the way we use S3 bucket is already hardened so that application owner will not expose their bucket to the internet. So this is a kind of service we provide to enable business instead of blocking them.
I think that I like the quote. Now, you want security to be a business enabler and not a business blocker. I think it's really, really important, and especially with the pace at which organizations are rolling out innovations and want to roll out new types of applications. So, I think as we talked about, just to summarize, I think what we so far talked about is as you roll out Kubernetes-based applications, getting the DevOps and security teams to work together, using processes, but using processes with a degree of caution that you're not choking the pipeline, so to speak. And then what about from a technologies perspective? If there are, as again, the section we're talking about here is that organizations are now adopting it. So which technologies should they carry forward? Which technologies should they invest in and fill the gaps? And how do you see this working out?
So, we want to have a version or a take of every major security technology adapted to Kubernetes, to containers, right? We want to have network segmentation. We want to have vulnerability management. We want to have security testing. And so I think a lot of this can be done with existing solutions adapted to Kubernetes. I think we need more tools that are specific, especially in the scanning side, that are specific to scanning Kubernetes, that can look for these specific things that are related to Kubernetes configuration, to Kubernetes architecture, that will just disappear if you run in, a general vulnerability scanner. And so these are the areas where I think you need to focus on, in addition to the traditional stuff. But at the same time, there are areas where you can worry less, right? For instance, patch management becomes sort of a non-issue if you continuously build your environment, because you set up a new environment from a fresh, clean OS build every day. So who needs patch management?
Yes, from my side, it would also be great to see more tools helping with risk management over container platforms, integrating all of the metrics like level of isolation, data classification, to simplify this life cycle management of applications in container environments, and getting these metrics on the associated risks. So I think we're still very early in this journey in most cases.
All right. I think the last question I have before we questions from the audience as well, really is about as you look into the future, what is going? I mean, as I think one of the things that Ofer you mentioned and Alex you mentioned, that there's just a lot of data that's getting collected, and applications are becoming bigger, they're becoming granular, they're becoming distributed, which means you have all this data that's going to get collected, and you need the haystack, but then you also need to be able to find that needle within the haystack. So where do you see are areas that we'll continue to see innovation in? So what is the future in this battle against cyber threats when it comes to containers and Kubernetes?
So I'm going to take my narrow world of attack of the attacks and identifying the attacks. I think we are at the very early baby steps of Kubernetes security and Kubernetes attacks. I think what we're going to see, and I'm very excited to see that, as a technologist, it's very interesting. We're going to see completely new types of attacks, completely new approaches and ideas, like we see in every new space, right? I've started with application security. It was young when SQL injection was innovative, and it was new. Cloud introduces new attacks. Kubernetes is going to introduce new types of attacks, new families of attacks, and it's up to us as an industry to research them and find them before the bad guys do, and build the solutions to block them and detect them before the bad guys take too much advantage of them. And that's why I love this space, because I love spaces that are new, that have what to discover in them. So that's my take.
Yes, and let me add to this that because most probably, unfortunately, attacks will happen. So it's about being ready for the attack and ensuring that you can actually delete your applications and nothing will happen, because your data is well protected and you can restore it when needed. So it is about taking these attack scenarios into consideration when designing the infrastructure and the architectures of the applications, ensuring that you can actually tolerate these incidents, and you can simply delete the infected instances, and you can proceed without impacting the business. So I think this is another consideration that we need to constantly keep in mind. Right? Let's accept that bad may happen. Let's ensure that we can handle these situations.
For the corporate, it's really important to understand the threat landscape, maybe using the security research work from all these brilliant people in the industry and the MITRE framework, to map the TTP to the exact which tools are we using, how much are we covered, so that we can have a graph to show those are the gaps we still need to invest even more.
Great. Well, thanks for, I think that was a great set of discussion, great set of answers here. We have a couple of questions that we can, from the audience. I think in terms of, there's one specific question where can I use my existing, security tools like firewalls or intrusion detection systems in a Kubernetes cluster. So do you, one of you want to take that answer?
So for the most part, unfortunately, the answer is no, right? Your firewall is not going to run well inside a cluster. And your IDS could in theory, but as we mentioned, you're going to need to set up this, set it up every time you spin off a pod or a cluster. And unless they are adapted to Kubernetes, it's just going to be pretty impossible to manage. So you need to look for tools that are building Kubernetes-specific capabilities, as we mentioned before, so that they would work well. They could be your existing enterprise security solutions, but they need to be adapted to work with Kubernetes.
Great, thanks. Thanks for that. I think there are a couple of questions, but they're kind of upvotes and similar to the ones. I think that probably is the list of questions I have here from the audience. So before we close the panel, are there any last words of insights that you would like to share before we close?
I think maybe we want to address one of the polls. One of the questions in the poll was, what is the level of your confidence in the security of your Kubernetes environments? And I find the answer interesting and disturbing at the same time. Only one vote, only 6%, said that they have high confidence in their Kubernetes, which is reasonable, but shows the maturity or the lack of maturity that we're at now. Most of the people said they have medium confidence, and given what we see in the industry, it makes me wonder if at least some of the people that answered this have sort of a false sense of security. Because I would say more than half of where we see Kubernetes used is not used securely enough. So just my small take on these poll results.
That's fascinating. That's actually, I would definitely agree with that as well, based on what we are seeing. Anything you would like to add, Alex, Chavo?
Yeah, my last would be still focusing on the process, because in this cloud world, people talk a lot about automation, but automation will not replace process. How to have this end-to-end process from threat modeling all the way to the way we do the incident response, I think that's a key.
And I will add that also using metrics on this, so that it will not be just at the engineering level, but it will be easier to communicate the status of the platform, of the containers, to the board and other executives, giving visibility on what is vulnerable, what are the risks, how to manage these risks going forward. And there are technologies to do this. It is about just using them to get the metrics and to simplify the decision making.
Great. Well, thanks everyone. A special thanks to you, Alex, for helping us put this panel together. Thank you very much to the panelists. I know for you are in Israel, it's really late right now for you. Thanks for staying up for us. And Shavo and Alex, you're coming to us from New York. Once again, thank you for taking the time out of your busy schedules. Everyone, I hope you had valuable experience attending the session and got a lot of insights. And stay safe, everybody. And we'll see you at the next summit. Thanks, everybody.
Thanks, everyone.
Thanks, bye.
Bye.